new cutting chip brake technology, high-speed triangle cut.
The triangle motion was applied over the entire cutting path. Now you can set the pitch at which the triangle motion appears. Between those points, the tool performs normal turning, significantly shortens machine time.
The chip braking, the effectiveness, we can see clearly. Hello machinists! I'm Shogun Nakamura from Nakamura-Tome. So, do you have such experience when you come to factory in the morning? So you see the machine, the fully automated by bar feeder and robot, and then you found the machine was stopped by long cutting chips. That is one of the most regrettable moments for operators. I have such experience. I think you have such experience. Today, we will figure out this big problem for automation. We will introduce our new cutting chip brake technology, high-speed triangle cut. That is the evolution of triangle cut we introduced before. So today, we invite my friend, Mr. Ishiyama.
Hello machinist, my name is Ishiyama. Nice to meet you.
So Mr. Ishiyama, so triangle cut is now well reputed by our customer. Already our customer use this technology very well in the factory. So what is new high-speed triangle cutting? What is the difference?
Great question. With conventional triangle cut, the tool continuously draws a triangular motion throughout the entire feed. This is very effective for chip braking, but there's one weak point about longer cycle time.
I can imagine the customer voice. Okay, chip braking is perfect, but how is the machining time? Can be shortened than the previous one?
That's why we developed high-speed triangle cut. The biggest improvement is this. You can now freely control how often the triangle motion is applied.
Okay, you said is control the frequency of triangular motion. What does that mean exactly?
Let's take a look at the actual motion. In the past, the triangle motion was applied over the entire cutting path. Now, you can set the pitch at which the triangle motion appears. Between those points, the tool performs normal turning. This reduces unnecessary cutting distance and significantly shortens machine time.
I see. So you only apply the triangle motion, so where it's really needed.
That's right. Now let's compare three cutting methods. On the left is normal turning. On the right is conventional triangle cut. And in the center is high-speed triangle cut. The cutting conditions are material 304 stainless steel. Cutting speed is 280 meters. Feed rate 0.1 mm. Depth of cut 0.1 mm. Cutting length 25 mm. With normal turning, the machining time is about 22 seconds. With conventional triangle cut, because the triangle motion is applied throughout the feed, the cycle time increases to about 67 seconds. But with high-speed triangle cut, the time is reduced to about 32.5 seconds.
So left one long cutting chip is tangle in the workpiece and cutting tool, and right one is slow, and the middle one is very fast. And I think this cutting chip can be breaking the small pieces. It looks so. That is correct?
Yes, absolutely. Here are the chips.
So this is a normal cutting without any triangle cutting, right?
This is triangle cut, and this is high-speed triangle cut.
Even the machining time shorter than before, but the chip braking, the effectiveness, so we can see clearly. I think great effect for real production. Even in stainless steel, that is difficult to cut long cutting chips to breaking small pieces. So it's good effect by our experiment.
Thank you. This function was developed directly in response to feedback from the shop floor. We want good chip control, but we also want shorter cycle time. That's exactly what high-speed triangle cut delivers.
I think so. Mr. Ishiyama team have lots of trial and error in the experiment, and finally develop new high-speed triangle cut. So that is a very impressive for me. Is this Nakamura-Tome original function, right?
Yes, both the triangle cut and the high-speed triangle cut were developed through extensive in-house testing.
Okay, sounds great. So I think our customer think about how to make this program for high-speed triangle cut.
The programming is very simple. This is the G code for high-speed triangle cut G338. Argument A specifies the finishing allowance. B specifies how many spindle revolutions occur during one triangle motion. C is the clearance amount. This has a default value, so usually no need to change it.
And D defines the direction of the cutting and also OD and ID and the left spindle, right spindle, that kind of that. What is E? That is the overlap ratio.
The overlap ratio defines how much of the feed overlaps with the previous pass. If E is set to 0, the two return to the same position, which may negatively affect surface finish due to the nose radius. We recommend setting E between 30% and 70%.
How does the overlap ratio affect roundness and surface roughness?
Here are the roundness measurement results. As the overlap ratio increases, roundness improves.
At 70%, it's clear. It's almost same value to normal turning.
And here are the surface roundness results. Higher overlap gives better surface finish.
I think Mr. Sherman, so overlap ratio is a nice function and higher overlap ratio and get nice accuracy. But how about machining time side? If we set high overlap ratio, it means the long machining distance, also longer machining time, isn't it?
Good question. We measured that too.
Oh, it shows that only the time gap from the 0% overlap ratio to 70% overlap ratio, just 1 second. Okay, we can get good chip control, good accuracy, and almost no increase in machining time by using overlap ratio.
Back to the program. This H parameter defines the triangle pitch. In other words, the distance of normal turning between triangle motion. This parameter activates high-speed triangle cut. To end the process, simply command G339.
So it's very simple G code, easy to use. So we have the many shape that is OD cutting, so of high-speed triangle cut. We showed before, so OD triangle cut toolpath for us. And now we have also the taper shape. So this machining method, can we apply for this taper shape for the workpiece?
Yes, it works perfectly on taper shape as well. And as we mentioned in the previous video, a triangle cut can also be used on machine with box guideways.
Okay, that's big advantage, I think. Our customer need to apply so this high-speed triangle cut to all the machine have the different structure. So if you have the limit, it's difficult to use, difficult to apply in the factory.
Also, triangle cut does not require any special NC options. It's purely a toolpath-based function, so it can be applied to a wide range of our machines.
Oh, that's such nice function. So Mr. Sherman, now I want to apply to my machine. When we can apply this nice technology to our machine?
It's already available.
Already done? Oh, big surprise everybody. Already done. If our customer have already normal triangle cut, how do they apply new high-speed triangle cut for their machine?
For customers who already have a triangle cut, you can upgrade free of charge through Nakamura-Tome software update service, NT Update.
So everyone, both triangle cut, high-speed triangle cut can be applied to any model of Nakamura-Tome lathe and multitasking machines. If you have the problem with long cutting chips, you have the several measures, of course. So chip breaker, cutting condition adjustment, and high pressure coolant. However, this is another new option for you. You can figure out this chip breaking problem by our triangle cut. cut technology. So please try on that new technology. So Mr. Shiyama, thank you for joining us and introducing nice technology for all over the world, all the machinists. So Nakamura-Tome will continue developing software, function, machining technology to cut the burden of manufacturing. If you like this content, Triangle Cut, please subscribe and press high rating. See you, machinists. Bye.